So what is a circle? What's the definition of circle? Anything that you know till now?
It has no sides.
That is correct. But it's like, saying what is an elephant. So elephant is a ball kind of thing or a rope kind of thing. So maybe we need a little substantial, and don't see the theory in case you got your eyes on that. What is a circle? I mean, it is correct. It's not wrong, but it's not entirely correct. Yes. Anything else you want to try?
So many points in that shape.
Okay, so it is formed with a lot of points in a particular shape. So when do we get that particular shape? So you are half done. When do you get that? Yes, Moita.
Radius.
When all the points are equidistant from the center.
Okay. Yes. So both were right. But I wanted a version that Moita shared. So we have one point, a set of points that are equidistant from one specific point. So if these are the points and it is, equidistant from this one point. Okay. So this is a circle, and this distance, this fixed distance, is known as the radius, and the fixed point is known as the center. Okay, now it is also a little sophisticated definition also is there. Locus of all the points equidistant from all the from a fixed point. So locus means set of the path of the points. That's what locus means. So locus or set of points, collection of points, it's the same thing. So now there are a lot of small details, definitions that we need to revise, or in case you are hearing that first time, bad, but still we need to revise. So first thing is diameter. Diameter is twice the radius, so it's not at all difficult. Twice the radius. Now what is arc, chord, and okay, first tell me this, then we'll come to the others. Arc. Yes, Mohita.
It's the distance between on the circumference between 2 points on the circle.
Okay. So it is distance between the 2 points. You're right and technically wrong. So, but you explained it, so I understood it. So it should be the part of the circle. It's not the least distance. I mean, the aerial distance. It's not that. Just we had in coordinate geometry, right? It's not the distance connecting these points. That is basically what? Chord. That is chord. So A to B distance, this distance is chord, and this red color, the part of that is arc. Okay, and this is the center. So you're right. I mean, so now what is segment and sector? Yes, Mohita. You're only two people. I mean, there is no. Yeah. Continue.
Segment is like the area that the chord produces till the circumference.
Okay, the area between. Okay, area between
the chord and the circumference.
Okay, so the arc and chord, the area lying between these two things would be the segment. Mudit, you wanted to answer this, or was that something else? Same. Okay. So segment is between arc and chord. And what is sector? Okay.
Is a
Mudit,
sector is
okay. Yes, yes. Continue. No problem.
is a sector is the area formed by two radius and a circle.
Okay, so this is R, this is also R, and the
Area between that and the
two
arc.
arc. Yes. So 2R and arc. Is that okay, Mudit? All right. Fine. So this is sorted. And now if you have one, okay, how many parts does this, what happened? Does this circle divide the plane into? So I have drawn this. This was supposed to be. So how many parts does this circle cuts this thing? 1, 2, 3, 4, 5, 10, 1, 3.
So can you repeat the question?
Victory. So it was how many parts does this circle bifurcate, divide this plane into? So Mudit says 3 parts. What's your opinion, Mohita?
So I still do not understand what the question is.
This is a circle. You see a green circle on the right, and it's drawn on a 2-dimensional plane surface, paper. So how many parts does this circle divide, separate, okay, into? How many parts? Okay, never mind. So it is this inside area and the outside area. So, and the circle itself. Okay, it happens when we. Okay, anyway. So this is 2 areas, and third the circle itself. So it is depending on what we convey and what we understand, it is 2 parts, or including the circle itself, the thread. I mean, if you are drawing it with a thread, so the thread itself, so that would be 3. So all right, now if we have, so everything easy peasy now, it's the same things repeating, and it would continue for the rest of the chapter. Things would be like this only, 90-degree tangent, 2-3 things, simple things, but the questions would be little tricky. Okay, let's see. Now if we have a circle and a point, so 2 things, 1 circle, 1 point. So what combinations we can have? Just like we studied in linear equations, 2 lines are there, so they could have different combinations, overlapping, and now I can't give you more hints. So what possibilities do we have for 1 circle and 1 point? It can be inside, it can be outside, it can be on the circle. Is that okay? All right. I don't know, you guys were stunned, like, what's going on? Circle and a point. I mean, the question was a overkill, but anyway. So we can have it inside somewhere, and on the circle, and outside the circle. Just ignore my sketching skills. So now, what possibility we could have for 1 line and a circle? 1 line, 1 circle. It's like, fifth, sixth grade topics going on. 1 point, 1 circle. Three possibility. All right. So you can explain, Moita, what it is.
One as a chord, one as a tangent, and one outside.
Okay, you know about tangent. So it is, one is a tangent, and okay, we have it here. So we can take NCRT's help, then relying on my aesthetic skills. So one is outside the circle, one is touching the circle, and another is intersecting at 2 points on the circle. So the first one is, there is no name, and this is a secant, and this is a tangent. And for those who have a past life notion of tangent from the trigonometry chapter, it is something related to tangents that we studied, but just give me a moment. Huh? Okay. So it is related, but even secant is related. But this we will not be discussing in, our 10th. And probably this you will have in 11th trigonometry. So it is related. It's not totally isolated. It is related, but we can't discuss it. I forgot first thing, and second thing is it would take some more time to get to that, but it is related. You studied about slope. You remember slope thing? Have you heard of that? In linear equation, slope m, you ever heard? No. So in that also, okay, just I would draw it for. So this, suppose this is a line. So this, it is 30 degrees, suppose. So this slope, this rise by, this thing by travel. So that is also related to tan. So I'm just hinting you that it is not totally isolated. What we have, the tangent here, and that we have for a straight line, and that we studied in our trigonometry chapter, Mudit. So Mohita, of course not. So it is related, but we'll not be discussing in detail. So that's the only point. Okay, so point is done, line is done. So now, if you understand this line, well and good. If not, then you can ignore it. Just see if that. Is that okay, not okay, medium okay? Okay. So, like to explain me? Because I don't know what it means. I'd like to try. No. So tangent, am I audible? Is my voice clear? Okay. So tangent to a circle is a special case of secant. So whenever we have this special case of thing, so it's a kind of, rectangle is the special case of parallelogram. Can you relate now? Square is a special case of rectangle or a parallelogram. Even that is possible. So when we have one thing given, and if you convert it to another form, or make some changes to it, so that becomes some specific case, special case, and that is what it is. So now for our tangent case, what it is if you note this BA, let me mark it. Just a moment. BA, this is a secant, it is intersecting at 2 points. Is that all right? BA, the first BA thing. Now, how it is a special case, this is a secant. So if you kind of twist it little bit towards the left side, it would reach to one specific location where it would be a tangent to this circle. That's what it means. Okay. Tangent is a special case of secant, nothing more than that. So it's plain definition of what a tangent really means. Mudit, you want to ask something?
So secant is a chord.
Secant is not a chord. Chord is a part. A chord is a line segment. This is a line. Secant is a line. And hope you know the difference between segment and line. Segment is line segment basically. Okay. Part of line is a line segment. Okay. Okay. Some more fancy things. So, how many parallel tangents can we have? 2. Okay, right and wrong. So how many parallel tangents can we have for a circle? Infinite. Okay. That was a nice explanation, a graphical expression. Okay, so this is, this chapter is little kind of that only, you need to figure out what they are asking, and it might be wrong also, although you know that what is right. Circle is dividing a paper, the plane, in 2 parts clearly, but then sometimes it is 3 parts, so we can't do anything about it. Depends, although you know the answer. So it's that kind of a situation. So you saw probably 2 tangents for this, and you answered it is 2 tangents, and for a specific point it is true. So through a specific point, if you take P dash Q dash, the left side tangent, then it is only 1 pair of tangents, two tangents. But for the circle in general, we can have, how many tangents we can have, that many parallel tangents we can have for that circle. So again, you understood, but kind of confusing. So now we are on the first, the most difficult topic that we will be studying till now. The tangent of a circle at any point of the circle is perpendicular to the radius. So this is the tangent, this is the center, and this is the radius. All the spokes are the radii of this, but we need only one. So at this point, which is known for obvious reasons, point of contact, because that's where the tangent is touching the circle. And for God's sake, don't just kind of ignore the printing issues. It's not many points, it's just 1 point. Theoretically, it's touching at 1 point. It's not a flat tire. It's a specific circle and 1 point. So now this is point of contact. Okay, so 3 things: radius, tangent, point of contact. If this is the case, radius is perpendicular or normal to the tangent at POC. That's this first theorem. Very difficult. Yes? Radius is perpendicular to the tangent at the point of contact. Mudit? Easy, difficult, medium? Okay, very easy. Okay, that's what it is. Now, what does that mean? You can get a triangle, right angle triangle, you can connect the center with, wherever you want to, and then we can apply the age old theorem known as Pythagoras theorem. So we could, do uh, something with that. So that's how this chapter is. We'll connect few things that we are okay when we have this example. So things would be like this. So we can conclude that at any point of the circle there can be only one and only one tangent. I hope that is not difficult. And the line containing the radius through the point of contact is also sometimes called the normal. So normal is 90 degree. Anywhere in math you get this thing normal. So normal is normally 90 degree. And also for ortho, a word is there, orthogonal. So this orthogonal, although in medicine it refers to bones. But for here it is 90 degree again. So normal, and it is 90 degree. Okay, so probably you don't have any doubts, and I have no doubt that you have any doubt. So we'll continue to the next set of questions. Again, very difficult questions. So first question, Mudit, I will ask one by one. First question, Mudit, although you answered this. What's the answer?
It's infinite.
Okay. Second first part, Mohita.
Secant.
A tangent to a circle intersects it in, fill in
Sorry,
the
sorry,
blanks
sorry.
first.
One. I thought the second
1
one.
point. Okay. So now you answered, so we can't allow that. Okay. Third is Mudit. What's third? This is what I asked. Third.
Infinite.
A circle can have infinite. I mean, but what I feel is they are trying to get to this, no, at most. So at most means they tend to ask that it is 2. So I'm just ignoring this question. So fourth, Mohita.
Point of contact.
Oh, very difficult. Please try the third one. Third question, MCQ. Just give it a try. I'll just back in a moment. You just give it a try. Make a diagram, mark everything, and use this concept. So, anyone done? Okay. What's the option? Okay. That's the right answer. Udit, what's your version of the solution?
Confused. I didn't get the diagram.
You should have asked, na. There is something called as asking. Okay. So, Mohita, please help us. We need your help. Yeah.
So there is a circle, and then there is a tangent starting from the point of contact is P, and so from P there is a tangent till Q, and the center is O. So OP is a line, and that is 5 centimeters, and you connect OQ to make the triangle, and by Pythagoras theorem you find PQ.
Okay is also given
OQ
12.
is, yeah, 12.
Udit? So actually, it is true. I mean, because I just hinted you, maybe you could intuitively do that, but it's little tricky because you don't know where this tangent is, reaching to, and it is confusing. A tangent peak at a point P of a circle of radius meets through a center O. I mean, it's a confusing. They could have made it easier, but this is what it is, and it is what it is. So, Mudit, is that okay? Root 119. You could get the answer.
Yes, sir.
Okay. So now we'll draw some more 5th, 6th grade sketching. So if we have if we had one line, one possibility was there, and with the circle, and now we have one point, one circle, and tangent. So depending on where the point is, we need to check how many tangents we could get to the circle. So first thing, we had three options in that. So first thing is if we had that outside. Okay, we will start with on the circle. So if the point is on the circle, and then we have, you can think about it meanwhile. And if we have it inside somewhere, this is P, this is also P, and then outside. So how many tangents are possible for each of these cases? So give it a try. Yes, Mohita.
For the first case, 1 tangent.
Yeah.
The second one, 0.
We can't have no tangent.
And
Third
the
case.
third one, 1. Okay, no tangent.
To the circle. The point to the circle.
So you can have two.
2. Okay. How?
One from left to right. Left is above and goes down.
You meant something like this. Yeah. Then we can have something from here, you know. Okay, we can have the point here. It's not Mudit's fault. It's okay. So how many tangents from one point outside? How many tangents to a circle is possible? Are possible? 2 tangents are possible. Yes, victory. So 2 tangents are possible. One is this and another is this, and probably you might have guessed if we connect the radii, the 2 radii. So this is, both these are going to end up being normal with a tangent. Yes. I would be thinking what an interesting chapter this is. Okay. Now we'll discuss this also. This is the last theorem, probably, if I'm right. Yeah, this is the last theorem that we have, which is again takes very long to digest. The lengths of the tangents from an external point of the circle are equal. So P to Q is equal to P to R. Okay. So how do we prove this? We'll go to 9th grade, that is proving congruency. So they have already made this set of two set of triangles. So anyone want to attempt how we can prove this congruent without seeing the explanation? Anyone wants to give it a try? Yes, Mohita. Probably you had a nice time in 9th. Yeah. Yeah.
So if we connect the P to O, and we get two triangles, POR and POQ. So in that, QO and OR are the radius, so they're equal.
Okay.
And
so
they're 90
this
degree.
Is one 90 degree. What else?
And the hypotenuse is common.
Yes. So OP is the hypotenuse, H. This is side. This is right angle. So RHS, congruency criteria.
So PO
These
and
two are
PR are equal.
correct. Now, this is what we needed and this is what we have proved. Now, based on CPCT, the corresponding parts of congruent triangle, we would also say that this P inside the above, the first triangle above the fold and below the fold are also equal. So QPO is equal to OPR. Right? OPR. And also POR is equal to QOP. Easy? All right. We need to keep this in our mind that this is also true whenever we are given a set of tangents. So OQ and OR is of course radii. So OP is the same thing. So, but it basically, it's this line joining the center and the point, the external point from where we are deriving these two tangents. That line would bisect these two angles, angle P as well as angle O. QOR, QPR. It bisects this. Okay. So now this is another proof if you want to, do so. Same thing. You have to prove it congruent first. Then by CPCT, the angles would be true, which basically means it is OP is dividing these two lines equally, bisecting this. All set? I will not go to this example. Okay, now again for few occasions in NCRT, if we start with the examples just of the topic, it's going to be a nightmare, and even the second example is kind of difficult. So you lose track of what's going on. So we'll do some basic things first and then come to. So there are 4 to 5 questions that are way beyond the level that we are on right now. You will think like the concepts were very easy, but then suddenly what just happened? So of course we'll be solving that and you will probably get the knack of it, but it is there's a gap. It's like out of 10 we are on 2 3 and then suddenly we have a 8 to 9 level of questions. So we'll be discussing that, and then from exemplar also, this is one chapter which has a lot of difficult questions. So maybe nearly 10 questions will be solving that are a little tricky. So 10 to 15 questions are little challenging for this whole chapter. Just comparing to what the topics are going on. So please try the first question. Although we have done this, just give it a try. First question. We'll do 1-2 more questions and then wind up today. Yeah. 10.2 first. Done? You got it, Mudit? Tell me.
So 7 centimeter.
Okay, these are the triplets 7, 24, 25. That's the right answer. Second one.
So I'm doing.
Yeah. Yes, Mohita.
It's 70 degrees.
That sounds about right. How did you solve this?
So like we can have it the two triangles, and 110 is because two angles are equal, so it's half. So divided by 2 is
55,
55.
55.
55, and because OPT and OQT are 90 degree, uh, because all three angles are equal to 180, you find it that way, and the 2 is that angle.
Okay.
That's
Mudit, did you try the same thing?
So if we know that it's a quadrilateral, then opposite angles of a. Okay, so it's not a parallel.
Exactly. Exactly. So because it's a quadrilateral, sum is 360. Right? So P and Q are 90. 90 plus 90 plus 110 subtracted from 360. That is also 70. So you can try either of the methods. You should have tried, I mean, your quadrilateral method is easier, but the tangent method is, I mean, the Mohita's method is relevant to this topic. So in exam, you need not do if it is an MCQ. That's not needed. But again, these are two methods and try to make it relevant. Um, okay, last question for today, third one. To get the diagram right, everything else probably is going to be easy. Yes, Mohita?
50 degrees.
50. So 90, 90, 80 is 330. No. 180 plus 60, 260. So 260 and 100 is left. So 100 would be bifurcated, divided into 2, 50. And if you want to make triangles, even that is possible. 40, 90, 50. So either way you do it, it's correct. Good. Mudit, you got this? Mudit?
Yes.
Okay. It seems I can hear your audio, but then it video drops. Okay, so we'll continue from here and we'll do these. So this is the summary of this chapter. Okay. So
Is that all?
yes, that is all. That's the chapter. It's worth 4 or 5 marks. Okay, 3 points and 4 or 5 marks. So pretty easy. All right, so we'll continue from here and let's see how things go. Okay, see you next time. Bye everyone. Bye Mudit. Bye Mohita.
Bye, sir. Thank you, sir.